Welcome to MRP classes. Today, let us discuss three important points in solid state. They are the fundamental points in the chapter. The understanding of these points are very important. The points are lattice points, crystal lattice, and unit cells. Let us go to the first point, lattice points. Lattice points are the constituent particles of a crystal. The crystal is made up of these lattice points. Depends upon the types of crystal, we have four types of lattice points. The first class is ions. Lattice points may be ions. Ions lattice points are present in ionic crystals. Let us check one example. Sodium ion and chloride ion can be the lattice points in sodium chloride crystal. Second types of lattice points are molecules. These are present in molecular solids. For example, one of the most common example is H2O molecule, which is considered as the lattice point in solid ice. Third is non-metal atoms. See, non-metal atoms can be the lattice points in covalent solids. The most common example is carbon as a lattice point in diamond, or it can be in graphite, etc. The fourth type is metal atoms. Metal atoms are the lattice points in metallic solids. Example is Au atom in gold, platinum atom in platinum metal, etc. Now I go to some important points of the lattice points. Let us discuss features of lattice points. Understanding of these features will help you to understand and solve many numericals for competitive examinations. One is lattice points are considered as spherical. Volume of lattice points can be calculated by the equation 4 by 3 pi r cube. And area of the lattice points. See, area of the lattice points can be calculated by 4 pi r square, where r is equal to radius of the lattice points. Therefore, lattice point can be considered like a ball. You can consider a lattice point like a ball, and r is the radius of this hard sphere. Now I go to the second point, lattice. What is lattice? This is the simplest definition of lattice. It is the 3D arrangement, three-dimensional arrangement of lattice points. See, there are 14 Bravais lattice. I tell you one funny example about a lattice. If you see arrangement of spherical sheets, for example, laddu in Kerala, in bakery, that arrangement can be treated as one kind of lattice. Now, we can go to the third concept, unit cells. Unit cell is the basic idea of any crystal. It can be defined as smallest repeating unit of a crystal lattice. For example, if you have a lattice, you cut the lattice into smallest pieces in such a way that you are getting a piece which cannot be further cut into any other size. That smallest piece is called unit cells. As we know, there are 14 Bravais lattice. Therefore, there are 14 types of unit cells. See, why we take unit cell as a concept? Because the formula, shape and arrangement of lattice points in unit cell is equal to the formula, shape and arrangement of lattice points of whole crystal. Therefore, we can say that unit cell is the replica of a unit cell is the smallest replica of a smallest replica replica of a lattice. One more point, density of a unit cell will be equal to density of the lattice density of the lattice. Now, how can we characterize a unit cell? Unit cell is characterized by two factors. One is edge length, second is interfacial angle. Edge lengths are represented by A, B, and C. Interfacial are represented by alpha, beta, and gamma. Suppose this is a unit cell shape. These are the three types of edge lengths: A, P, and C. This is A, this is B, and this is C. Suppose this is a unit cell. These are the three types of angles: alpha angle, beta angle, and gamma angle. Thank you for watching. If you like the video, please click like button and please click like button and please subscribe my videos. Thank you.